Well, hi, good morning. Thank you so much for joining me here on May 31st. Oh, last day of May. And cold here. Man, it is really cold. We've had to turn our furnace back on to keep the house warm. I think it went down to 6 degrees overnight. It's 12 out there right now. 8. I think it's 8. I think it's 8 degrees outside. Oh my gosh, it's cold anyway. Yes, and I should complain because it's now the end of May. It shouldn't be this cold. Well, what about this radio? Yesterday I found out that there's a really good chance, with a little bit of effort, I can get this whole motorized system operating. So I'm going to leave that alone now and move on to dealing with some of these old capacitors that you see in the radio here. So I'm going to do this in some kind of logical fashion, I guess. I'm going to start with the audio stages of the radio and clean up the old capacitors. I will be testing the capacitors as I take them out, but there's really little chance of any of them being anything other than really needing replacement, even though the radio worked to some degree. So I keep pointing down in this area. This is where the output tube is, down in here, and so it's probably these guys that are going to go. Basically, everything beyond the volume control. The volume control kind of sits with the radio on one side and the audio on the other side. In other words, radio frequency stuff on one side and audio frequency stuff on the other. Kind of like that. You can think of it that way. So we're going to be working on all the audio stuff from the volume control forward. First place to start, though, is taking a look at the schematic and see what kind of trouble I'm getting into here. Let's take a look. Okay, so the area we want to look at is to the right of the volume control. So right here we see the volume control. Basically everything over this way. It's just 4 tubes. We have a preamp, an inverter acting also probably as a preamp. Each one of these driving one of these output tubes. This is kind of an odd arrangement if you've never heard of this push-pull type thing. It's a clever design where each output tube amplifies only half the signal. So this might be amplifying the positive half, and this might be amplifying the negative half, and they get reassembled here in the transformer. Excuse me. And there's a lot of benefits to this. One is these tubes don't draw a lot of current when there's no signal, and so they're efficient. And you get a lot of power. You got 2 tubes operating here, so you get double the power you would from one tube, roughly speaking. The challenge is you have to add in some way to invert the signal for one of the 2 tubes. So that's what this is doing. So the signal's coming along and being, I don't want to say split, but it splits into 2 versions. One, let's call it positive version, and one negative version, if you like. And so you can see with that in place, with one of these inverted, the sine wave would be upside down here. And so what can pass through here can't pass through there, and vice versa. Does that make any sense? I don't know if that made any sense at all. So a few other things about this circuit. Let's zoom in a little bit on here so we can see a little clearer what's happening. So we want to look at the grids of these 2 tubes, the signal grid. Follow it back. You can see it eventually gets to the plate of this tube, and likewise, same thing be happening up here with the grid on this tube. Now, there's a capacitor here. The job of this capacitor is to pass the signal, but not pass any of the DC voltage that's sitting on this plate. So there might be conceivably a couple hundred volts sitting here, likewise up here. We don't want any of that getting through to the grid. Now, how is the grid biased? Good question. So we follow this line, we follow this, it's working its way back to here. This would be the most negative place in the radio since they've applied the ground here. There's a voltage divider running between the output, running across the output of this tube, if you like. So they're applying some voltage here. It could be minus 5 volts, minus 10, minus 15. I don't know what it is offhand. There's some resistors here, but there should be no current flow in the circuit, so there shouldn't really be a voltage drop here. There's a lot of resistance to get through, 100,000 and 270, so it's getting close to 500,000 ohms to get to the grid, but again, no current flow in the grid, so no voltage drop on here. And the very same thing being done up here. These two capacitors are of particular interest right now. If these capacitors are leaking, then some of the pressure on this side from the high voltage will push charge through onto here. The charge will start leaking down these resistors, heading for wherever it's heading. Now, in some cases, this will cause the grid voltage to go very positive. In this case, because it's held by these resistors and the technique they've used back here, I'm not sure. Other tubes, other circuits rather than make the grid negative, they make the cathode positive. It has the same effect on the tube. Those ones, the grid is really exposed to a leak from here, but I'm not so sure about this one. What we need to do is figure out what the correct voltage would be here. I can just look at my book and see what typical bias voltages are on the grid here. Then we can measure these voltages and see what they are. Then we can change these two capacitors and measure them again and see what the voltage is. In this radio, I'm not sure if it'll make much difference, but in other radios it can make a huge difference. The problem with the positive voltage here is it causes the tubes, it causes a couple problems. The tubes conduct a lot more. The grid might conduct a bit. That's not a terrible problem. But the tubes conducting more, they're just wearing out that much faster. And if it gets really serious, then the tube will distort and the sound won't sound right. So basically, the output tubes are put at risk by these leaky capacitors in most of these old radios. And these tubes generally are the rare ones because they're output tubes and they wear out quickly. So that's why it's so important to check these. Now, what about this guy? He's in the plate circuit. Oh my gosh, what's it doing? I'm not sure. I think I followed it wrong. Let's follow it again. Grid. So what's happening here is they're taking the signal from this tube, applying it to the grid of this tube, and getting the inverted output here. Okay. Now, what about the grids on these two tubes? We can follow those back. So this is the one that's picking the signal up from the volume control, right? And then it's passing its output down to the grid of this one to generate the inverted signal. So this is probably heading towards a switch or something. Why is it going way down here? Yeah, down to the audio switch. So this is something we'll be testing today. We'll work the switch and make sure it operates properly. It may be dirty or who knows. And then there's the Victrola jack. I'll be feeding a signal into here to operate the audio so we can check it. Capacitor there. So how does the volume control get its signal? Well, then it must be coming down from the switch and back up again on this other line. Here's where it's getting the output from the radio, right here. So this is a diode detector. This is the output from the radio, so this is an RF signal here. It goes through the detector, and by simply rectifying it, you can recover the audio signal. Then you want to get rid of some RF that might be left. Let's see. So here's a 1 to 10 voltage divider, most of the voltage appearing here. And off to the top of the volume control. It goes down, comes back up into the volume control. This is the part you're moving on the volume control. This part here, some of the signals peeled off and sent on its way. We have something funny going on here on the back tab. So often engineers really get pretty fancy in this part of the radio. They start fooling around with things to try to generate the kind of tone that they want, the proper tone that they're after in the speaker. And sometimes they'll actually feed feedback back into the back of the volume control and do other things to create a situation where when the volume is low, the bass and the treble are boosted. That's not what's going on here, though, I don't think. This would look like some kind of filter. Like this capacitor was going to filter out the higher frequencies. The higher the frequency, the more the filtering. So maybe that is what's going on. In a sense, I'm just guessing this, okay? When you turn the volume control down into this range, a very low setting, you are also setting it where the treble has been robbed by this a little bit, and so your tendency is going to be to hear more bass. The problem is our ears don't hear well at low volumes. This is a problem with our ears too, not just the radio. Okay, but there's nothing here to be too concerned about. That's basically what it boils down to. So we're going to have a little bit of DC here, blocked here, but really nothing is threatening these grids that I can see. Really, I'll take that back. This grid depends on this capacitor because the plate voltage is sitting right here. So we have this one, this one, this one, and there must be, and well, maybe this one also. Any one of these leaky could shoot some DC where you don't want it. This one would have to go through the volume control. If you're cranking the volume control up and down, it might make the DC voltage on the grid go up and down. I don't know, maybe I'm talking through my hat. Okay, so we need to find these capacitors now. I'm going to look for this one and this one, these three first, if I can find them. Good luck. I bet you I can't even identify them because they're in the midst of circuits here. Like, yeah. Okay, enough talk. My cats aren't hanging around today, but I'm going to show you a picture of my cat Wally and what he was up to yesterday. That's him there in the window, as you can see. What's he doing there? He's looking outside. That's what he right outside that window is our deck. Yeah. There we go. Okay, so I've looked in my book here, and the grid on a 6F6 output tube is pin number 5. These are the two output tubes here. So we just have to count pin 5. There's 1, 2, 3, 4, 5. And there's a capacitor right there. We do the other tube. 1, 2, 3, 4, 5. And there's the capacitor right there. They both look the same size. That will be them. So the job of these two is to block the plate voltage that may be coming from. It would be this tube here, blocked from getting here, and this is the other inverter tube there. Is that what that is? I'm just looking. Yes, it is. Okay, that's so the signal's coming from this tube through the capacitor into this output tube, coming from this tube, an inverted signal, through this capacitor to this tube. But I don't know which one's inverted actually. We want to measure the voltage on the grid of these two tubes relative to the chassis, I guess. Cathode is really important, really where we want to measure it. Measure the voltage between the grid and the cathode on those two tubes and see what we've got for bias on them. And this is kind of a backwards way of checking the bias arrangement that's going on because of this resistor over here. Okay, that'd be the plan. I have to turn the radio on to do that. I think it's get my coffee ready time. Okay, time for a very short story here. I was just drinking some coffee, watching videos. Canadian like me, complaining about things kind of like I do once in a while. And he makes this statement. He says, you know, your stuff was not made here. It was probably made in Vietnam or made in China. And he says, well, I'm going to take off your shoe right now and see where it's made. So I did that. I took off my slipper. Here it is. It says Manitoba. Manitoba. But that's not spelt properly. Manitoba. But inside is a tag. So I took a look at this tag. And it says country of origin, Australia. Australia. I'm wearing Australian slippers. So much for what the guy said in the video. Anyway, not Vietnam, not China. Australia made my slippers. Thank you, Australia. Now, let's get over to here. So 6F6, 5. I've already done all that. Jim, I'm just catching up with myself here. I'm going to use this kind of voltmeter because I don't want to use my vacuum tube voltmeter because I'm going to be not reading to the chassis, and it might be a little precarious to use a plug-in meter. I've forgotten about my other. I have another meter I could be using. Okay, but we'll use this one. Now I'm going to turn this on. I'm just about to do it without thinking. I don't have the speaker plugged in. That's not going to work. That's not going to work out. Okay, I gotta stop here. Okay, repeat after me. Cathode is 8, grid is 5. Cathode is 8, grid is 5. We're gonna hopefully be measuring a fairly small voltage here, but we don't know. We don't know what we're gonna get. Okay, radio's off. I'm just going to practice. So what I want to do is put this on 8 and put the positive one on 5. Let's try this tube first here. So 8 would be right here. So I'd be like that. And then 5, the one with the capacitor right here. So I do that. I'm going to get a reading on the meter. And I would expect it to be, well, I don't know the answer to that. Let's find out the answer to that. So we're looking at the 6F6 here. Typical operation. Fixed bias, that's what we're using. The 285 is my guess. Minus 20 volts. Minus 16 for a little lower B+. So pretty high negative voltage here, derived from those resistors in the power supply. Okay, and of course that voltage could be reduced, the negativity of it could be reduced by the positivity coming in. Does that even make sense what I just said? It sounded good. There we go. Radio on. Okay, just firing it through the dim bulbs first. Oh, okay. Why don't we read the B plus voltage up here, just to get that in my head, because I don't know what it is. Speaker's going. We'll read it right, not necessarily B plus, but right across this capacitor here. 240 there, and reading across this one here. What happened there? I didn't do that. Ooh, 370. Oh, I didn't do that either. Did I? I don't like that. It's not me doing that, is it? No, I don't think so. Coincidence. Okay, something going on, but you know, could be these capacitors. Now we'll do the test. So we put the negative on the cathode, which is pin 8. Get on there. And then we go pin 5. 1, 2, 3, 4, 5, where the capacitor is here. You should see there's negative 19 volts there. So that would sound pretty appropriate. Now we'll try the other one down here. I think the case with the radio like this is the leak in these capacitors is not enough to throw off the voltage that's fixed by some, you know, series of resistors. That. So I'm not surprised. So there's 8. No, that was 1. This is 8. That's 8. And 7, 6, 5. This is capacitor. And also a similar voltage. And I'm yeah, I got full voltage on the radio. So they're both tubes are receiving appropriate bias. So the capacitors are leaking, they're not causing a serious problem. Kind of phooey on that. Okay, let's just check the other two tubes. I can just there were more capacitors that could be responsible, if I remember. Stop mumbling. Okay, let me check. You can hear the radio crashing in the background a little bit. So what I did was I quickly scanned all these tubes to see if any have a cathode resistor, and there isn't a single tube in here with a cathode resistor. They're all grounded cathodes, and that means they're all getting their bias voltages from these resistors here. And sure enough, if you trace this one up here, it will work its way to the grid and on up here. Well, to a plate. Okay, never. My story went south there. Okay, good enough though. So what that means is there isn't the same concern in this radio of a plate voltage leak. Say like this tube is isolated from this tube's plate circuit by a transformer, and same thing here. We come back further. What about these ones back here? So this first tube, very first tube in the radio, is getting its signal right from the antenna. What's this all about? This is probably AVC coming along here. That's probably the AVC capacitor. See the AVC voltage fed to the grid of the magic eye, and the AVC voltage developed by the detector. It's like an accidental voltage that was ignored in the early days, but was soon recognized as an opportunity to feed a negative voltage. So these tubes are, their bias is controlled by this DC voltage generated here, not coming from the power supply, not fixed. It's variable bias. Okay, and it's just typical of all these kinds of radios here, and it's applied to. Screen grid, wrong one. The radio's gone quiet. Yeah. I'm going the wrong way. It's coming from here. There's a very large resistor. There's usually a large resistor. So you have the source of the DC here. goes through a large resistor into a circuit that should draw no current because it's just going to grids. So there's no voltage drop here, but it provides a huge amount of isolation. Otherwise you've literally got the output shoved right back into the input here. Well, do I see a capacitor of any concern here from the point of view of charging up a grid accidentally? I don't think I do. This grid here, yeah, see, it's all transformer isolated. So yeah, okay. So this general concern with these old radios of a leaky capacitor driving a grid positive, not applicable in this radio. Okay, so what's my best approach to doing this now? Let's look back at the radio. Could be the best thing I can do now is just go in and just kind of do them randomly, because I can't think of any interesting way of doing it other than just, you know, start at the bottom and work my way up. It's all these right in here. Okay, that's the plan. How many should I do before I test the radio? How big a gamble do you want to take? Okay, so you know, these are the two capacitors I'm after, and there was one right across here where I have the clip lead clipped into this one. I took it out because it was in the way. And here's something interesting about this. It was in like this. You see the little bit of solder on the end of the lead there. That's not the terminal. The wire continued on to the terminal. It looked like this wire has been cut and then resoldered back. And you know, that's an indication of some kind of test being done on the radio. Is that what happened? I don't know. Who knows? Who knows what the story is? Maybe they just splashed a little solder on there. It doesn't really look like it. Oh, for the first time I'm getting some company here today. Where you been all this time? Both of you and your brother have been very quiet all morning. You've been into some kind of really big trouble. Okay, keep going. You're not showing your best end there. So the problem here is the value of this capacitor is not really legible. Or is it? So it has a number 700 there, and then I think I can see what looks like 6035 on it. And look at the, please, get your arse out of here, buddy. If you look on the schematic here, after checking pin numbers and doing all that kind of stuff, I resolved that in fact it's this capacitor here. My cat is using the camera as a face rub. Come on. Oh my gosh. Anyway, this one here, which is one I was after anyway. So I do this one, and this one all at once. Doesn't that sound like an exciting thing? And I put the clip lead in so I don't forget where it went. And did I show you the size? It is 0.0035. And you look at this again, you can kind of see 0035 on it. It's a big thing. This is this capacitor has more capacitance, but it's a smaller package than this. Maybe it's the voltage. That's a pretty high voltage. Okay, so I've got the two new ones here. I need a 0.0035, and we'll put them in. Okay, ended up doing 4 capacitors, 1, 2, 3, and the tone control capacitor. Those ones, you know, I could be mistaken in this, but I think what I've done is this one, this one, this one, and then the tone control capacitors right here. Okay, that's enough. You know, doing capacitors without testing the radio in between, danger, danger, danger. Let's make sure the radio is operating. So move that over there. Okay, now we're also going to test all these capacitors that I've taken out. But first, let's test the radio. Okay, everything's good. Here we go. Okay, dim bulbs first. and everything looks fine. Okay, something we can start making an observation on is the watt draw on this radio. So we're 107 volts, 75 watts, which sounds pretty normal actually. 78. These things usually 80, 90. Big radio like this, maybe 100 watts. 80. Okay, no problem there. 106 volts. Still doing this scratchy stuff, which I think is because of DC going through the control. This one's nice and quiet now. Is it working? No antenna. No sound. Push buttons. The button is pushed down. We want the tuning button down. Okay, volume down. Tuning button without touching the. I can't stand the idea of putting my hand on the chassis and then pushing that button. I gotta stabilize the radio. Oh, there we are. Okay, so the most right hand button is pushed. No antenna, Jim. So I'm gonna connect the antenna here, but it's not switched on. But it seemed to help last time, so volume down. We are dealing with the audio circuits here, so it really isn't a radio issue as such. We gotta. Oh, that's right. I was gonna feed a signal, and okay, let's do this. I can't finish the thought. It's picking stuff up. What band are we on? Ooh, it just did that click thing again, where the radio's receptivity clicks up, I think clicks down again. Something going on. Okay, what band am I on? No idea. Okay, the band I want to be on is the... Oh, I do have an idea because this is working up here now. Right. There we are. Now we're on the broadcast band. Oh yeah. Sure. Weird stuff, but this descending tone, probably due to one of these capacitors in here, up in this area. And can we get any station at all? Let me just look at where we are with the capacitor. Okay, should be in this area. Well, I'm sure it's working. Yeah, I'm really not too concerned. Okay, we want to stick an audio signal into this guy. Tone's working. Audio signal into this guy. So to turn on the phono, we push this other far button here. Phono. Ooh. Why those aren't? That's right, and I don't think it locks in. Does it? Lock in. Yes, it could. No, it won't. There we are. Okay, so I've locked it in. As far as I know now, the phono input is active. Where's the phono input is located in a silly spot here. So they put the phono input right near the push buttons. I guess what they're trying to avoid, I don't know, trying to avoid running a piece of wire. I don't know. So I want to just touch it. Well, I can see it from here actually. So if I just get a screwdriver, volume down, go up here, touch this thing. So that's definitely the input. There's a capacitor on it there we should get rid of. I can phone it. I can feed in a audio tone, and it's not going to prove much because it's a sine wave. It's just not going to prove much. So we don't bother doing it. What would be better is to actually hook up a Bluetooth receiver right now, or some other music source. Bluetooth would be the best way to do it because we're actually modeling what could be done with this radio, but not until that capacitor is changed onto there. Capacitor I'm talking about phono input. Where's the phono input? Where have they hidden that? I saw it before. I did see it. Somewhere around here is a phono input. It's right near a volume control. For some reason I can't spot it right now. But I'm sure it's nothing more than a I can't spot it. Nothing more than just a series capacitor with the line lead. Okay, so I'm going to change one more capacitor, then we're going to feed in audio. Well, you might get a kick out of watching my cat help me do this. He's really moved in. And just positioning the second wire here from the capacitor I'm putting in. Okay. I'm guessing you can hear him purring. I can certainly hear him. So Bert here is fairly laid back, as you can tell. His brother, Wally, that's the one who's... did I show you that picture? Did I show you a picture? I think I did. Now I'm going to try to saw it aside. So I did show the picture, I'm sure. Leave this cord alone, cat. On your head. Leave it alone. That's it. Leave that alone. Don't bite it, that's for sure. What a mess. Lots of smoke. I think I got it. On that end. The other end I did. Didn't I? No, I did not. It's really hidden in the back here. Soldered. This other end. Looks like it's barely soldered. What do you got planned for today, Wally or Bert? Doesn't look like it's soldering all that well. Well, thank you for not going crazy on my soldering iron cord. Good guy. One thing he's really taken a liking to, this guy, are the little knobs on the top of radio antennas, and goodness knows I have a lot of those around. And every time he sees one, he wants to go over and chew the knob on the antenna, which you can imagine the kind of problems that causes. Okay, so we have the capacitor in here. What we're going to do next, we're going to test all these capacitors that I've taken out today. There they are. I'm going to check them all. Find out. Come on over here. We'll leave the cat to be by himself here. Let me tip this down like this. There we go. Okay. First one, this would be the two grid blocking capacitors. And as I think we saw from the tests I did, it really isn't that critical in a radio of this sort. It does not have cathode resistors. The bias voltage is pretty solid, so Okay, there we go. So you might be able to read it says 25 there, but in fact when I hit the switch it's 50 volts. And guess who's coming to join us here? Here he comes. Are you going through? Just passing through? Yes. Okay, here we go. So that popped open. We can see it close momentarily. And it opened right up. Next test. Here comes the cat again. Oh, he's moving the camera this time. Don't headbutt the camera. I'd show you what he's doing, but I can't because this is the camera here. Okay, my friend, we're doing another capacitor. Oh no, did I get that up to a higher voltage? Wait a minute, I got distracted. Put it back on. Let's put it back on. Okay, good. Higher voltage. Wow, okay, this capacitor is testing quite good. Really quite surprised by that. Okay, that's one. Not severely leaking. Okay, we'll hook up another one here. This is the other grid blocking capacitor. 50 volts. See, this one's not opening now. Not quite as good, but as capacitors go, even that one is not nearly as bad as so many. This is the one that was in the way. What was it doing? I can't remember. Let's see if whatever it was doing, was it doing a good job of it. There we go. Okay, so that popped open awfully fast. I did see it close. You probably can't see it on the camera, but there's a momentary closing. Higher voltage, please. Higher voltage yet. So I'm suspicious that this capacitor, this is a small one. This is the 0.0035. Let's hit it. Let's hit it with 350. Wow. It's snapping so fast, I have some doubt about it having capacity. But certainly not leaking. Not leaking. I'm impressed. This is impressive. I've tested thousands of capacitors over the years, and out of a radio like that, they're seldom this good. Okay, here we go. Another one that tests good. Even on this voltage. What about let I have it? Even there. Wow. Okay, so now I'm thinking, well, the value in changing these capacitors not as high as I might have imagined. I don't know which one this was. Maybe I got them mixed up a bit. This might be the other grid blocker. First grid blocker I tested just like new. Well, maybe not like new, but okay, here we go. See it? Now the eye won't open. So this guy's a bit more of a leaker. So all in all, showing signs of age. Appears as if the grid circuits in that really not exposed to anything because of these leaky capacitors, which aren't as leaky as many capacitors that I've done before. Many capacitors, I hit it with the 50 volt in the first setting, and the eye closes and doesn't open at all. Unfortunately, it's a qualitative test. I can't really know quantitatively what's going on with these. Okay, so we're going to feed in an audio signal and listen to this radio and try to judge the quality of the sound from it. And that'll be the end of today. It's another long video. You know, I'm losing track of time here because I'm having so much fun with this radio. Okay, so we're ready now to send an audio signal, just a sine wave. Could do a square wave too for some reason, through the radio just to hear the speaker. One thing we can look for is speaker rattles or something like that. And you know, how low and how high can this go? Now it's not in a cabinet, so its low frequency response is going to be greatly reduced. This is the signal generator I'm going to use. Let me turn on the attenuators here. Let me turn it on first of all. So right now it's set to 560 hertz, which is a mid-range tone sort of, and the output is extremely low. In fact, it should be pretty much zero, so we really shouldn't hear it. Okay, the radio is on. Of course, the radio itself is not part of this. Here we go. Just dim bulbs again. for a moment. Okay. Bit hummy still. A little scratchy on the tone control. Volume. Okay, so you hear the hum come briefly while I'm turning the control. The control is losing contact inside, so it's still not clean enough to that scratchiness could be related to this capacitor, which is still in the circuit. Well, I don't hear a thing. Okay, so we're going to turn the volume up about halfway, and I'm going to start increasing the signal level here. Hopefully we'll start hearing a tone. Oop, I hear it. Let me take off some of these patterns. There we are. Okay, volume here. Very good. Okay, so this is a sweep generator, and I can make it go from one low frequency up to a high frequency and just sweep through them all. So why don't I set that up for fun? So we'll put the start frequency a little lower here. Way down, way down. This must be the stop frequency. Start frequency way down. I'm gonna get a shock here if I'm not careful. So that's starting at 90 now. Okay, I have to change the settings to go lower. We'll start it at 90, which is pretty low, and we'll finish off at some crazy high value. Well, you know what? I can only go up to 1,000 hertz this way. Okay, that'll be good. So we'll go from pretty low to 1,000 hertz. Okay, volume down, and away she goes. Whoop, I said away she goes. She's not going. How come not going? What's the matter? Uh-oh. This guy should be rolling right along. Well, maybe it is. It is going along. This is the average frequency it's showing here. It's sweeping at a very high rate, so I'm going to slow it way down. Okay. Why are we not hearing it? That's interesting. Because did I do something stupid here? Main out. I put my finger on that thing and we heard it before. Think. What are you doing wrong? Now we got a button pushed, which is the audio button. Did I not make a connection to the? Oh, here we are. You know what? Stupid of me. I didn't turn the volume up. How long was it like that? To check a speaker, to check a speaker for rattles, you really have to turn it up. And there's not going to be any rattles in this speaker, I'm sure. Let's take it down. Way down. So that sounds a little buzzy. That should be a pure low tone, but it's not. Something's a little rattly in here. Interesting, but I don't know what to make of it. We'll go the other way now. We'll go way up high. This is going up to 10 kilohertz. Sounds perfectly fine to me. Okay, so what we're going to do is we're going to stop the sweep. I'm going to fix the volume, fix the frequency. This is 8 kilohertz, which is a much higher sound. Every time I see the frequency and hear it, I think, wow, It sounds way higher than I expect pitch-wise, but so I'm going to manually increase the pitch of this until I can't hear it anymore. It's up around 10. I can hear that. You probably can't. Maybe you can. I don't know. I can hear that. And of course, my own hearing is part of this, but my hearing is good. I know from doing stuff like this. Okay, well, I think really, you know, unless I were to play music through this, we really can't judge it fully. But I don't think there's any problem whatsoever with the speaker. The audio circuits sound great, even though there's still some capacitors left in it. And that's it for today. I am done. So tomorrow we'll clean out the rest of these capacitors that are in the audio circuits, and then move on to the radio circuits on the next day. Thanks a lot for watching, and see you later.